Hello my dear students, we are once again back with the new tutorial for the subject of statistics, the class 12th English medium part 1 chapter 4, that is the time series by yours only Vitan sir. In the last tutorial that we studied, we learned about the least square method of computing time series problems. Also, we studied about the estimating of future or past values based on the time series equation. Also, we studied how to depict the linear equation on a graph. Now, in this tutorial, we will see the solution of exercise 4.2. So, we will start with the exercise 4. The first question is the information about death rate of a state in different years is given in the following table. We have to fit a linear equation to find the trend, that is number 1, and estimate death rate for the year 2017, that is number 2. Now checking out the T number wise, it is 9, 10, 11, 12, 13, 14, 15, that is 1, 2, 3, 4, 5, 6, 7. So 16 and 17 will be the 9. So we'll have to take T as 9 in the answer. Now let us copy this data into our table. We will start with the year first, 9, 10, 11, 12, 13, 14, 15. Then comes the death rate, that is the Y variable here, 7.6 and so on. Next will be the T variable, which we will convert here into 1, 2, 3, 4, 5, 6, 7 and then square this column to get the T square. Now death rate here is the Y variable, so we will get T into Y as Ty column, and once we get this, we will make the horizontal totals here. So next we need here is n is 7, so T bar, that is the total of T, 28 upon 7, 4, and Y bar is 49.9 upon 7, that is 7.13. So we will need the totals of the columns and T bar and Y bar. We will start with the formula here, which we have already done so many times throughout many chapters: n summation Ty minus summation T summation Y upon n summation T square minus summation T the whole square. We will put the values from the table, the total of the columns, into this equation one by one according to the symbols and then multiply them. The last one will be a square, of course, 28 square, and then subtract them to get negative 14 upon 196. As you can see here, the value of B is going to be negative 0.07. So this negative means rest of the signs for next formulas will change. It will be opposite. As you can see here, the formula for A is Y bar minus B T bar. We will put the values of Y bar, T bar and B into our equation. As you can see here, negative negative becomes positive. You will multiply 4 with 0.07 to get 0.28 and add that into the 7.13 to get 7.41. We will put the values of A and B into our time series equation, that is Y cap is equal to A plus BT, putting the value 7.41 plus negative 0.070, that will make it negative 0.070, plus minus becomes minus. Now what we have to do, that we have to estimate for the year 2017. As the year is 2017, the T will be assumed as 9 in the equation. So we will take T as 9, put it into equation, multiply it with 0.07 to get 0.63 and subtract it from 7.41. You will get Y cap as 678. So in the year 2017, the estimated death rate will be 6.78 in a state. Now we will move forward towards the second question of the exercise. We have the data about cost inflation index declared by the central government as follows. The year 1981-82 is the base for this index. Find the estimate of this index for the year 15-16 by fitting the linear equation to this data. That means we have to fit a linear equation and then get the estimate for the years 15-16. The year 15-16 are in continuation with the given data, so immediately next T value will be taken for the finding of the equation. Right now we will copy this data into our table. We will start with year 7, 8, 8, 9, 9, 10, 10, 11 and so on, and once we get this data we will write down the value of y variable, that is the cost inflation index, into the table. Now the conversion of years into t's will be 1 to h, and then we will square the t column to get the t square column, 1 4 9 16 and so on. The last column is the ty column, which multiplies the t and the y columns. As you can see, the data is big. You have to be careful while calculating and copying down the answers. And once you are done with that, you have to make a total of all the columns. Next, we'll be finding the bars. T bar here will be 36 upon 8, 4.5. Y bar here will be 6076 upon 8, 759.5. The n is 8. Now we will take all these values and put them one by one into our equation. We will start with writing down our formula for B, that is the time series coefficient of time series. Then putting the values into our equation, we will multiply them. We will get two sets of subtractive values. We will subtract them, and then by dividing we will get B as 69.40. Now we will put this value into our A, that is y bar minus B T bar. Y bar 759.5 minus 69.4 into 4.5. We will multiply first, and after multiplication we will subtract them to get A as 447.2. Now take the A and B values and put them into our time series equation, that is A plus BT, that would be 447.2 plus 69.4 T. What we have to do, that we have to estimate for the year 2015-16. As we know, the T here will be 9. Up to 14-15 it was 8, so the next year will be 9 here. You have to go chronologically one by one. Okay, so put T value is equal to 9 into our equation for y cap, multiply B into T, and then add that into our A to get y cap 1071.8. So the for the year 2015-16, the estimated cost of inflation index will be 1071.8 in the nation. So this is the estimate which you will get from this index number. We will move forward with the third question of the exercise. The number of two-wheelers registered in a city in different years is as follows. We have to use the method of fitting linear equation to this data to obtain estimate for the number of vehicles registered in the years 2016-17. That means first we have to fit the linear line, the trend line. Then we have to estimate for the vehicles registered in the years 16 and 17. That means for 2 years we have to estimate, and then we have to find trend values for each year. That means from 2010 to 2015 we also have to find the trend values. That means we have to find many things. We will move forward one by one, doing what we can. We will start by copying the data into our table, the years 10 to 15, then the number of vehicles in thousands as it is in the question, and after that we will convert the years into the t variable 1 to 6, and then we will make a square of the t variable to get t square, and then we will multiply t with the y to get the ty column. Once you have got all the columns perfectly, you have to make a total, horizontal total here. Don't just copy these columns down in your notebooks. It's better if you calculate it on your own. Then here n is 6, so t bar will be 21 upon 6, that is 3.5, and y bar will be 5, 33 upon 6, that is 88.83. Once you have got all these columns and averages perfectly, we can move forward. We will start with the B, n summation ty minus summation t summation y upon n summation t square minus summation t the whole square. We will put the values into our equation from the columns total, and once we put the values, we have to multiply these values with them according to signs, and then subtract them, divide them to get B is equal to approximately 9.06. Now we will put this value of B into our value of equation of A y bar minus B T bar. that would be 88.83 minus 9.06 into 3.5. We will multiply it first, and after multiplication we will subtract to get a 57.12. Now we will take this 57.12 and 9.06 into our time series equation, that is y cap is equal to a plus bt, that would be 57.12 plus 9.06 t. Now we have to estimate for the year 2016 and 17. So first we will start with t for the 2016, that would be 7. We will put that 7 into our regular equation, and then we will multiply it with 9.06, and then we will add the answer into a, that is 57.12, to get 120.54 thousand. These are the vehicles in thousands. Next we will take 2017 as 8. We will put it into our equation to multiply it with b and then add the answer into a. That way we will get 129.6 thousand vehicles. The statement here will be that therefore in the years 2016 and 2017 the number of two-wheelers registered will be 120.54 thousand and 129.6 thousand respectively. There was one additional question that we also have to find trend for all the years. That means you have to take t as 1, 2, 3, 4 and 5, and one by one you have to put the value of t into equation and find the trend for all the years. Now this is something I want you guys to do on your own. You have to solve it and write it down besides the original table given in the previous slide. So you have to do it on your own, consider it a homework. Now the last question of this tutorial, the average age of women in years at the time of marriage obtained from the data of different census surveys are given in the following table. Okay, we have various census surveys and the age of women at the time of marriage, the average of this data is given. 1971 is 17.7 years, okay, and in 2011 it is 22.2. So gradually the data is increasing. What we have to do, we have to fit an equation number 1 and then estimate for the 2021, that is number 2. So two questions are there. First fit the trend line, second estimate for the 2021, and also we have to show that trend on the graph paper. Okay, you will need a graph paper for this. So 1, fit a trend line, 2, estimate for 2021, 3, show it on a graph paper. Okay, we will start by copying down the question into our table. Years are given, then we will copy the age of women, the marriage age of women, and then we will convert years into t variable 1 2 3 4 5 and then square that t variable as usual 1 4 9 16 25, and then we will multiply the marriage age of women with t variable, that is ty column, and then we will make a total here 98.1 15 55 304.8. Good. Now the usual n is equal to 5, so t bar here will be 15 upon 5 3 and y bar here will be 98.1 upon 5 19.62. We will move forward with our regular formula and sum. B here, the formula is usual, and summation dy minus summation d summation y and summation d square minus summation d upon whole square. We will put the value into the equation here one by one. Don't mess up with the values, you will not get the answer right. Carefully multiply and then subtract them and finally divide to get b as 1.05. Put this value of b into our equation of a y bar minus b t bar, putting the value y bar 19.62, b 1.05, t bar 3. Multiply b with t bar first and then subtract it from the y bar to get a 16.47. Now put this into our time series equation, that is y cap is equal to a plus bt, putting the value of a 16.47, b 1.05 t. Now what we have to do is we have to estimate for the year 2021. So naturally t here should be taken as 6 chronologically, as it is in the sequence 1 2 3 4 5 and then next comes 6. So we will put 6 into our y cap equation. 1.05 into 6 will get a 6.47 plus 6.3, that would be y cap is equal to 22.77 years. So what we are assuming here is that in the year 2021, the estimated average age of women at the time of marriage will be 22.77 years. Now what we have to do here is we have to depict the whole data onto the graph paper like the next slide here. First, you have to draw the graph here. As you know, the minimum data was 17.7 years. I'm not showing this data from the 0, rather I am starting my data from the 15, and then 1 centimeter is taken as 1 year. So 15, 16, 17 up to 23 years as the maximum data available is below 23 years. I have taken years 1971, 81, 91, 2001 and 2011. On the x-axis, you can also take 1, 2, 3, 4, 5. Both are valid, it's okay. Now I will start with my original series. The original series, what it was showing is depicted on the graph paper here, and next the linear series I am showing on the graph paper. So this is the linear series which I have shown here. These guys have done a trick with us, because if we want to show the linear series, we actually need to estimate for the all years. So just like the previous question, in this question also you have to take t as 1, 2, 3, 4, 5 and one by one put them into our equation to get this linear series, else you will never get it. That means you have to do this sum once again, put the values of t 1, 2, 3, 4, 5, put it into our trend equation, get the answers, and then depict them answers as the linear series. So this is what they wanted us to do. If you don't do it, your marks will be naturally cut. This is a whole 5-mark question, remember it. So your homework for this, as our exercise is over, your homework for this tutorial is completing the whole exercise twice. Remember, twice in your notebooks. If you are only doing it once, you are not learning it properly. Doing twice means you will remember it better. What we are going to next time, we will be doing that we will discuss the moving average method, the last method for this chapter, and it is very easy method, and you are sure to get 5 out of 5 marks out of this method. So we will do the moving average method of solving time series problems. So till next time, till the next tutorial, stay tuned, see you soon, stay home and stay safe.